go. So we're getting ready for the big test on factoring. And this doesn't look like factoring, but it actually is factoring. Drop it like it's hot. Multiply. Add. Multiply. Add. Multiply. Ooh, it came out to 0. What a coincidence. No, of course, a lot of times they come out to 0. Not always. But since that's the remainder, would you please write what the remaining numbers mean? And we shouldn't. What do they mean?
They're the factors.
Good. So x plus
1.
and then
Then it's x squared minus x plus 5.
nice. Now, did you even think about whether or not you could factor that? All right. If you thought about it, you win. If you didn't even try, you lost, because a lot of times on the test it would factor again. Now, would this one factor again? No. So then you're done. Cool. Now, what could you say about the roots? Would you agree that this for sure has one real root? All right. Now, this one's less interesting because you'd have to use the quadratic formula to figure out the roots. And if you get the square root of a negative, you'd know they'd be imaginary and all that. Let's imagine that you just got done and your actual answer came out to this. Are you done factoring? Then finish it. It's actually a real one from SpaceX. I'll show you. So I got to go tour one of the SpaceX factories, and they gave us this as a optical. A real one? It's a real one. SpaceX. That's the rockets. Oh, cool. Yeah. They gave them out as like a little souvenir for people that took the tour. I was in California at one of their rocket factory plants. All right, did you know this was x plus 1 and x minus 1? And did you know this one was x plus 1 and x minus 1 with one important addition? I. Now, you don't have to say one I. One I and I are the same thing. Okay. Now, why do I like that? Because then, when I ask what the answers are, it's clear that there's 4 of them. And that 2 of them are imaginary. See, if you don't factor this part, if you leave it, you're going to maybe think that there's 2 answers for this and then 1 answer for that. No, there's 2 answers for that. It's just really easy if you solve it the other way. And you're going, okay, x squared plus 1. Here's the old way to do it. Minus 1, x squared equals negative 1, square root, and right here you can mess up because you think it's just x, and it's not, and you think it's just I, which it is. It is just I, but you forgot that, which then leads you to the plus and the minus. But see here, I can tell there's 2 different answers because there's 2 different blanks here. One of them's 1i, because 1i minus 1i would make it equal 0. The other one's negative 1i, or negative I. All right. There's a lot of things to review, and one of them is this kind of problem. I'm going to say that that's 4. And I'd like to say that that is negative 5. I'd like you to tell me the equation for this one and what kind of roots it has. Write the equation for it and tell me what kind of roots. The roots are the 4 and the negative 5. What do you mean, what kind are they? Well, you're supposed to know that they're not normal ones. See, when you made your equation, I bet you had an x plus a 5 for the 5, and an x minus the 4 for the 4. But did you know that since they bounced, they are squared kind, and that means that they are, well, there's 3 kinds. There's single roots, double roots, and triple roots. Those are both double roots. What would a triple... Oh, wait, and did you even think about the fact it was going up on the right? Because if you didn't, what if it was going down on the right? You would have had to put in a negative. And if you didn't even think about that, you wouldn't have remembered to put in the negative. So look for that tail. And if it's going down, you'd have to put a negative. All right. So write this equation. I'm going to start off with one of these, which you're supposed to know what kind of root that is. And I'm going to end with one of those. Oh, wait. No, I'm going to make it go back down again and go like that. And I'm going to say, what's the equation for this? If that spot is 0 and that spot is 5 and that spot is 10, what's the equation? And what kind of root are they? Single, double, triple. All right, I'm also going to weirdly label this spot as 7, 6. You might be like, why would you need that? For increasing and decreasing. All right, so what's the equation? Y equals. Well, I'm going to start with first things first. I see a 0 there. I'm going to put x plus 0. I would allow you to do that. What's simpler than x plus 0? Just x. It is a triple root. Did you realize that? It's that special kind where there's an inflection point where it changes from slowing down to speeding up and how fast it's increasing. Okay, and then this other one is x minus 5, and it's a special kind because it's a double root. And then this last one is x minus 10, and it's just a normal one. Now, if it gets weirder on the curviness and it was like this and then like that, you could ask me, like, did you mean for that to be like a triple root? You know, like if you can't tell for sure by my sketch drawing whether or not that's doing the inflection thing, you could ask me. All right. There's my answer, except I'm wrong. Why? Yes?
Negative.
Yes. How many of you, be honest, how many of you remembered it? Ooh, that's most of you. Good. Okay, now I put in the 7, 6. You should be able, there's one point here that kind of messes you up such that you can't even tell what the interval is, but you should be able to tell me one increasing interval that you can for sure know and one decreasing interval that you can for sure know. If you don't know what I mean, I'll show you in a minute. Write an interval where it's increasing and an interval where it's decreasing. This is the point 5, 0. You know that because it's on the x-axis, so its y is 0. And these intervals are always parentheses. Don't do brackets. That's for range and domain. It increases from 5 to 7 and from 7 to infinity. It decreases. Raise your hand if you had that one right. Sweet. Okay, a lot of things to know. If I gave you this equation, x to the third minus 3x minus 1. What would you be able to tell me about it? Yes.
How many homes and the ends and the y-intercepts?
Very good. What is the y-intercept?
-1.
Negative 1. How many turns does this thing make? Well, the most number of turns it could make is 2. 2. It's 1 less than this. I know it goes through -1, and it must make at least, well, actually, the most turns it could make is 2 turns. So it might do something like, that's 2 turns. It was going up, then it was going down, and now it's going up again. That's considered a turn, and that's considered a turn. It can make 2 turns. Now, who can tell me how my graph is for sure wrong? Yes?
It's supposed to go down on the right.
It's supposed to be going down on the right because of that. So now I'm going to erase my graph and try again because it's supposed to be going down on the right. All right. Well, maybe I'll start with that. Here, I'm going down on the right. Now I got to go through that point, you know, because it goes through -1. And how about that? Is that possibly right? Do you get that the ends are going opposite directions? Does that fit? Yeah, because the degree is 3, so it's got a y-intercept of -1, so that fits. All right. Now, the odds of it being exactly right are extremely low, but because I didn't really look to see what the x-intercepts are. All right. So if I wanted to know what are the possible x-intercepts, aka roots, aka zeros, there's a little fcon thing that'll tell you that. What are the possible roots of this thing? Because maybe my graph, maybe I can tell that there's no way it's right because of the possible roots. No, that couldn't be. Fcon over Fco, and don't forget the plus and minus. Factors of the constant. What are the factors of the constant? Well, 1, because 1 times 1 is 1. That's why 1 is not prime, because 1 only has 1 factor. And prime numbers have 2 factors, 1 in themselves, which I know seems like a catch-22, but 1 is not a prime. Factors of the coefficient are on the bottom, and the coefficient is a 1 also, so then I guess the only factor is a 1. So, do you get the only possible roots are 1 and -1? Do you get there's no way it could be those 2 things? See what I mean? I know for my possible roots, the only thing I could have is plus and minus 1. And I can't have this root and that root and that root. It's not possible. All right. So maybe my graph is actually like this. Do you get how that also goes through -1? That also has the ends going opposite directions, which fits. And it's only got 1 root at -1, and maybe that's the one then. Okay. All right, good enough on that. Let's see. Can you tell me all the real and imaginary roots here? Tell me the real ones. Not just how many, like what are they? And all the imaginaries. Not just are there any, but what are they? Okay, the real ones are the ones that are simple and like this one's 0 because it makes the whole thing 0 if you put in 0. 0 is one of your real roots, but you have to say x equals 0. You can't just say 0. Have I pounded that hard enough to say you can't just give numbers like 2? All right. X equals 0 and x equals 3 are both reals. And now I got to think about this, whether it's real or imaginary. Now, do you get, if I put anything in here, there's no way to make that come out -3? And therefore, these are imaginary because there's no way to really do it. Because this would have to be -3. So these are imaginaries, and there will have to be 2 of them. If all they wanted was how many? There's going to be 2. But if I actually have to get them, I would do it with that fancy way of factoring that I showed you. X plus, x minus, and it's got to have an I. And I use the square root of this, which you just say square root of 3 then. Now, if you can't do that, you don't have to. Remember I said this is optional? Then my brightest kids will do it that way. But if you can't do it that way, then you got to go x squared plus 3 equals 0, and you got to solve it very carefully. -3 minus 3, x squared equals -3. And you have to remember that square root, absolute value of x. If you forget that, you lose. I root 3, and there's my I root 3 coming out. And then I make this into 2 parts. X equals I root 3, and x equals -I root 3, and that's a lot of work. Look at all the steps. Or you just factor it like that. Okay, so my 2 imaginary answers, -I root 3 and +I root 3. And I would cry a little bit and mark that wrong. What's it missing? X equals. See, I had them here. X equals positive and -I root 3. Okay. Next, let's not forget normal factoring, but by grouping. Remember how to factor by grouping? It's one of those tests that has like 13 concepts on it. Pausing for a second. Okay. I like to just make a little squiggly line. This is not required, but it helps me focus on the first 2 parts. Come out x squared, and then I got x plus 3. And then this part comes out with a -2 comes out, and I got an x plus 3. And if these aren't coming out the same, then you're doing it wrong. Or it just doesn't work. X plus 3 was the common factor. When you divide by that common factor, which is technically what you're doing, then you are left with x squared minus 2. How many roots does this thing have? 3. Careful. How many are real? All 3. Because you can make that equal to 2. There's a way to make this part equal 0. If you have to, write out this and go, can I make that equal 0? Can I make x squared equal 2? Oh yeah, you can. Square root of 2 works. And square root of 2 is not imaginary. So that has 3 real roots. Okay. All right. We're getting close to you being really ready. All right. Last one I want to do is If I just said factor that, there are two different approaches you could take, and one of them is way harder than the other one. So without judging yet which one would be harder or easier, do you know a way you could factor this thing? Describe a way, Benno.
Factor the x out and give it back to grouping.
Ooh, factor the x out. Did you catch that? There's an x in everything. That would be the easy way. The hard way would be to try to do factors of the constant, factors of the coefficient, do long division except with synthetic, and then you'd be like, wait a minute, it doesn't have any number at the end. And then you'd have to put a 0 at the end, and then that looks really weird. It's so much easier to just notice they all have an x in them. Factor that out, and you'll have x to the third minus 3x squared plus 2x minus 6, and then it factors by grouping. See how there's an x in everything? All right. And now, as I promised, I wanted to give you a fair amount of work time where you can work on that remaining part of the packet that's like a review test. If there's any of those that you don't understand, you should ask. And there's a key for it too. So finish that up. That is assigned. It is going to count as homework. So work on that. And then if you get stuck, come on up and ask. Tomorrow is the test. That's all I got for you for today.